Product and quotient rules, Part 1. Both the product rule and the quotient rule can be found using the limit definition of the derivative. However, you're not expected to prove that these rules exist, you're just expected to apply them. So for the product rule, we're taking the derivative of two functions that are being multiplied together. So we have one function times another function. And when this is the case, the derivative of that product will be equal to the derivative of the first function times the second function without taking the derivative, plus the derivative of the second function times the first function without taking the derivative. Or sometimes you'll see this written as the first function times the derivative of the second function plus the second function times the derivative of the first function. These are equivalent by the commutative properties of multiplication and addition. Sometimes people prefer the first one, sometimes people prefer the second one, but they are equivalent. You'll mostly see me using the second one. For the quotient rule, we're asked to find the derivative of a quotient, so one function divided by another function. And the derivative of this quotient is equal to the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. This one can be a little tricky to memorize, so sometimes people like to remember this as the derivative with respect to x of the high function over the low function. So then this is the low d high minus high d low all over low, which is low squared. Let's use these rules to find f prime of x for each of these functions. So here we have f of x is equal to e to the x plus 2 times 2x plus 3x to the fourth. And here we see that we have two functions being multiplied. The first being this e to the x plus 2, the second being this 2x plus 3x to the fourth. And this is a product, so we have to use the product rule. Sometimes when people are starting to use the product rule, they'll find the derivative of each piece individually. So I'm going to call my first function h of x, since my overall function is f of x, so I can't double up on that notation. So I have h prime of x is equal to the derivative of e to the x plus 2, so that'll be e to the x plus 0. And g prime of x will be equal to the derivative of 2x plus 3x to the fourth, which will be 2 plus 12x. So f prime of x is equal to the first function, so that's e to the x plus 2, times the derivative of the second function, which is that 2 plus 12x. And I'll put my derivatives in brackets just to make it a little clearer until I can color code. Plus, so I have my first times my derivative of the second, so I need my second, which is 2x plus 3x to the fourth, times the derivative of the first. Then color coding, I have my first function times the derivative of my second function, plus my second function times the derivative of my first function. And then there's just a bit of simplification or factoring I can do here. So the 2 and the 12x both have a 2, so I'll factor out that 2. So I have 2 times e to the x plus 2 times 1 plus 6x. Plus, looking at this next term, I see that both of these terms have x's, so I'll factor out an x. So I have an x times 2 plus 3x to the third times e to the x. And this is my derivative, f prime of x. Now we have f of x is equal to 3x minus x squared all over 3 plus 4x. And this is a quotient, so we will have to use quotient rule. So we have that our top function is this 3x minus x squared, and our bottom function is this 3 plus 4x. And if you'd like, you can find the derivatives of each of these separately if you're having trouble keeping track in your head. So the derivative with respect to x of 3x minus x squared is equal to 3 minus 2x, and the derivative with respect to x of 3 plus 4x is equal to 4. So now using quotient rule, f prime of x is equal to low, so 3x plus 4x, d high, so the derivative of our numerator, which is 3 minus 2x, minus high, so our numerator as is before taking the derivative, d low, so the derivative of our denominator, which is 4, all over low, so that's our denominator squared. So we have low, d high, minus high, d low, all over low. And then we just want to check for any sort of simplification that can be done, so any sort of factoring. So if we look at that first term, there isn't anything to factor there. We just have our 3 plus 4x times 3 minus 2x minus, well, we have an x in common here, so we can factor out an x. And let's bring that 4 to the front, just so it looks a little nicer. So we have 4x times 3 minus x all over 3 plus 4x squared. And you want to be careful here. Although we have a 3 plus 4x for our first term, there is no 3 plus 4x for the second term. So we can't cancel out any 3 plus 4x's. Don't know why there's stuff left behind. So this is our derivative f prime of x. Here we have f of x is equal to e to the x over 4x, and we want to find the derivative. This is one function divided by another, so we must use the quotient rule. So in the numerator we have e to the x, and in the denominator we have 4x. And now we can find f prime of x. Be sure that as soon as you're taking the derivative, you write that you're taking the derivative. Otherwise it looks like a strange simplification. So we have f prime of x is equal to low, so that's 4x, d high, so the derivative of e to the x, which is still e to the x, minus high, which is e to the x, times the derivative of our denominator, which is going to leave us with 4, all over low, so that's 4x all squared. So we have low d high minus high d low, it's still high later, all over low. Then we want to do a bit of simplification. So we have a 4 and we have an e to the x in each term. So we can factor out 4e to the x, coming from this 4, and this 4, this e to the x, and this e to the x. And we're left with x minus 1 all over 4x squared gives us 16x squared. So our 4 will divide out, and we have e to the x times x minus 1 all over 4x squared is our f prime of x, so our derivative. We want to find f prime of x, so the derivative, if f of x is equal to e plus 2 to the x times 2x cubed plus 2 over x plus x root x. Keep in mind that this e is a constant. It is not a function. There is no x attached to it. So it is just the number e. We have one function times another function, which means we will use the product rule. And as part of that product rule, we'll have to take the derivative of each piece. So let's rewrite this second function so that we can use the power rule as we take that derivative. So we have e plus 2 to the x times 2x cubed plus 2x to the negative 1 plus x to the first power times x to the 1/2 power, which gives us x to the 3/2 power. So our first function is e plus 2 to the x, and our second function is this 2x cubed plus x to the 3/2. So f prime of x is equal to our first function, e plus 2 to the x, times our second, the derivative of our second function, so 6x minus 2x to the negative 2 plus 3/2 x to the 1/2 plus our second function, 2x cubed plus 2x to the negative 1 plus x to the 3/2 times the derivative of the first function. The derivative of e is just 0, and the derivative of 2 to the x is 2 to the x ln of 2. And now we need to just simplify this and rewrite any of our negative exponents. So we have e plus 2 to the x times 6x minus 2 over x squared plus 3 square root of x over 2 plus 2x cubed plus 2 over x plus x root x times 2 to the x natural log of 2. And that is the derivative f prime of x for our function. We want to find f prime of x if f of x is equal to a over b plus cx cubed. We have a quotient, so we will want to use quotient rule. As you look at this function, you'll notice a lot of letters. This a, b, and c are all constants, so they're not variables, which means we'll treat them like numbers as we take the derivative. So we have f prime of x is equal to our low function, b plus cx cubed, times the derivative of our numerator. The derivative of a constant is 0. So this is our low d high, minus high, which is a, times the derivative of our denominator. So b is a constant, its derivative is just 0, plus 3cx squared. Just treating the a, b, and c like they're numbers, since they're constants. And this will be all over low, so all over b plus cx cubed squared. Then we just have some simplification. This has been multiplied by 0, so it will cancel out. And we have just negative 3acx squared all over the quantity b plus cx cubed squared. And that is the derivative of that function. Just be careful that you're treating the a, b, and c like constants.